Welcome to Beyond Tech, where innovation meets insight.
We're your hosts, Jackie Slaght and Jennifer Palumbo. We bring curiosity, clarity, and a passion for technology-driven storytelling to every conversation.
That's right. And today we're here to talk about the metals industry, which is facing significant transformation. As we head into 2026, manufacturers are under pressure to increase operational efficiency, reduce energy consumption, and meet sustainability goals, all while navigating volatile raw material costs and global supply chain challenges. Companies must modernize legacy systems, integrate advanced automation, and leverage data analytics to optimize production and ensure quality while addressing workforce shortages and maintaining safety standards. In this episode of Beyond Tech, we're diving into these industry challenges with a panel of experts from eTech Group. Carmelo Bottari, Dave Jancosek, and Nish Patel.
Carm is a vice president of metals at eTech Group. He brings decades of experience in automation and control systems for steel and aluminum producers, helping clients implement advanced process control and digital transformation strategies to improve throughput and reduce costs.
And joining Carmelo is Dave Jancosek, vice president of metals business development at eTech Group. Dave brings decades of hands-on experience in the metals industry, starting his career as a technician and advancing all the way up through a variety of roles across multiple sectors. His deep understanding of the operational challenges and strategic priorities in metals manufacturing allows him to provide clients with practical, forward-thinking solutions.
And rounding out our panel is Nish Patel. Nish is the director of corporate development and strategy at eTech Group. He brings a macro perspective on industry trends and strategic insights and has been joining us for all of our industry episodes. So thank you, Carm, Dave, and Nish for being here with us today. I've really enjoyed these conversations with the industry experts that we've met with so far, and I'm looking forward to this one. So to start, I'm going to start with hopefully an easy question. That easy isn't the right word, but what are the top priorities that you're seeing from your clients in metals as we head into 2026, and what are kind of their challenges and priorities? Carm, do you want to kick us off?
Sure. I think primarily one of the biggest challenges that our customers are facing is having to deal with antiquated controls equipment and being able to have the right staff on hand to be able to properly handle it, to be able to troubleshoot it, bringing new staff on hand to be able to train, to get up to speed, to be able to properly handle this equipment. Safety is all a big concern. The steel industry the environment isn't what it used to be 20, 30, 40, 50 years ago, right? It's a concern, the ergonomical concern for the operators with the type of work that they have to do on a day-to-day basis, the environments that they're exposed to, the conditions that they're exposed to, all of those are becoming big concerns, as well as environmental factors as well. I mean, you hear a lot about the steel makers, both for the integrated mills, as well as the companies operating things like electric arc furnaces and things like that, talking about, green steel, clean steel, trying to minimize the number of pollutants that they're throwing out into the environment as they're going through their processes and their operations. Dave, is there anything you want to add to that?
I agree with you 100%. The legacy systems is what has really handicapped our customers for many years. Digitation of that equipment to get into their level 1, level 2 systems. But the legacy systems just don't appeal themselves to automation. So where they're trying to automate to get more yield, more productivity, manpower reduction, it's really hard to do with old systems, drive systems from the 60s, 70s, and 80s that are still, an installed base. So a lot of what we do is look at, the big picture holistically. What is a pickle line, a galvanized line, a cold mill? Is the line geared into where it was originally designed from the 70s and 60s? Can we get more speed? Can we get more productivity? Can we automate the entry in and provide, better throughput? So all that kind of ties together. And as Carm mentioned, not only that, you have these old legacy systems. Graduates out of school don't know analog systems or these old PLC systems. So who do they have to maintain it as their workforce ages and they need to replace their maintenance people? So it's quite a dilemma for them today.
I was going to say that. I mean, it almost seems like it's insurmountable. Of course, it's not. They're doing the best that they can. But what is that looking like for these companies with all of these challenges? Obviously, it sounds like huge investments needed, but probably not always available. So what are they doing to tackle these challenges?
It's a capital intensive industry. You hear crazy numbers like 100 million, 200 million, 100 million for a blast furnace, 100 million to 500 million for a hot strip mill upgrade. But these are investments they have to make. Part of the Nippon U.S. Steel deal was the heavily capital investment Nippon is currently providing for U.S. Steel to get them into the 21st century. It's something they deal with every day. At the same time, they have to produce. A lot of what we do as far as retrofits, trying to keep our fingers in the dike, we say, and surgically put a PLC in one area where maybe it gives them more return of investment is what is a good example. And maybe I'm talking with our group in the steel shop at U.S. Steel. I mean, they are there day in, day out, working sometimes 10, 12 hours a day because that process can't stop. So it's a fight.
Well, and that's a big part of what we provide as well, is we provide that technical consultative, like Dave said, on-site 5, 6, 7 days a week, because that's a lot of what they need as well, right? It talked about the antiquated technology and having, like Dave said, trying to get kids coming out of school that know the technology but can work with it, but also want to work with it, right? I mean, it's a very competitive workforce, right? I mean, how do you convince some of these smart engineering kids coming out of school, these controls engineers, to come work in an environment like the mills versus working for an Amazon or some of these deep pocket tech companies, right? So they're combating that as well, right? I think there's probably a stigma that they're combating as well, right? People have this image in their heads of the steel mills and say, is that the type of environment that I want to work in, right? Is it sophisticated? Is it the technology on it trending, right? Is that where I want to be? So they have to combat with that as well to try to attract, the right labor. But in the interim, that's where we come in, and we provide decades of engineering and steel mill experience with their technology and their processes, and we give them the technical help day in and day out that they need to keep the processes running and keep them innovating as to where they need to be investing in their processes and upgrading their systems.
Yeah. Nish, what are you seeing in the macro view of the metals industry heading into 2026?
Yeah, I'd say, from a macro standpoint, and maybe a bit sort of double clicking on what Carm and Dave also just noted, I think it's super important is metals really is at a turning point, especially manufacturers where very old equipment is essentially trying to keep up with new expectations. You've got the priority that we're hearing on our side is how do we sort of modernize legacy systems while also trying to support the level of speed, quality, performance, throughput that the market expects now. Many mills or process lines historically have been built to kind of be mechanically sort of sound, and they were built to sort of last for a lot of years. Controls layer is not exactly that. This is 20, 30 years old and is out of date. And that's really what's really limiting performance for customers generally from what we're seeing. So the challenge is you can't really just rip out a cold mill or a pickle line. Downtime is simply too expensive. And as Dave sort of noted as well, this is a very, very capital intensive equipment and industry in general. So the real focus is staged modernization. You're upgrading PLCs, drives, tension controls, while sort of keeping production running. And I think that's really the balancing act you're going to continue seeing heading into 2026 and really beyond as well, which is modernizing without paralyzing production. And I think really it's driven by 3 key macro drivers. One, it's really increased capital spending. You're seeing a lot of reshoring activity. You're seeing a lot of federal policy that's supporting essentially a push for domestic production. And we're going to continue seeing that. 2, energy efficiency, it's historically sort of been a buzzword. Now it is a real sort of priority, and we're going to continue seeing that as well. And then 3 is just tighter quality and sort of consistency expectations from customers or just all downstream industries. I think when you couple all those things together, you're going to continue seeing modernization being a really impactful thing that will continue to kind of happen in the metals industry, and we're going to see that.
Yeah, if I may, Jackie, hopefully you don't mind. I'm dominating questions here for a minute.
Go for it.
But Dave, we talked a lot about the concept of modernization and how big of an investment it is. And I mean, we're talking about big equipment and big CapEx spend. What does it look like with our core metals clients when we talk about modernization and advancement?
I think we can all agree we're seeing a lot of activity. A lot of activity because they should have had this equipment changed out decades ago. So they're like 3 renovations away from where they need to be. The other thing, Jennifer, is not only the equipment and the throughput and the yield that we talked about, their market has changed. They're definitely challenged today in the steel industry. We had a conversation the other day. Years ago, if you drove into a steel plant with a Honda, Toyota, Subaru, boy, you really got a lot of grief from that. Today, if you drive in that gate with a Ford F-150, it is 10 times worse. So the aluminum is really challenging the steel industry, and that's where the capital investment is. How do you combat the cost of aluminum and its drive towards the automotive? Over the last 10 years, they've been investing in high-strength steels, light-gauge high-strength steels, which the equipment was never designed for. So it's much harder to run it. The investment on the machine side has had to be done. At the same time, for example, we're working on a cold mill, and our lead engineer, Dan McCullough, is looking at speed and torque curves along with mill upgrades of the equipment so that we can draft the mill for these special products so that our customers can be competitive in the auto industry. And I've tried to give some content to some other than, hey, we need to change out parts, right? We got to change out this. We're not part changers. There's a whole methodology. And years ago, am I going to invest $100 million in this hot strip mill, or should I put $100 million in the bank and get 3% interest? Normally, if it's not a 12 to 18 month return on investment, they're not going to put their money in it. So it's very well analyzed. The projects are approved at the board level, and it's a must-can-do investment at all our customer sites.
Do they rely on us for that, like to help them with the prioritization, or do they already know what they're going to do?
Absolutely. They rely on us heavily. I'll give an example, the 84-inch pickle line, and where we looked at the gear ins, we looked at the throughput. We did a tension study that Nish talked about to actually look at what the capabilities of the bridles and all the equipment were. We look at catenary calculations, things like that, and say, okay, this is what you need to do to get this line back up to speed and to produce these high-strength steels. We worked with Prime Metals at the time, the machine builder, to put more bridle rolls in, to put more lubricant capacity and all those things. And it was about a $120 million investment, and we did the electrical drive system, but it was all done as a collaborative effort between us, the machine builder, and U.S. Steel.
It makes sense.
I mean, with the staff augmentation that we provide, when I say that we provide the consultative resources, they're on staff to basically keep them running, and it's our senior engineers, our experienced engineers, kind of responsibility, their duty to say, what does it mean to keep you running, right? I mean, you can only put Band-Aids on the same old antiquated equipment for so long. So our staff isn't just there to troubleshoot equipment; they're there to be involved in project planning meetings to say, look, you're already at the 11th hour here on this equipment. I can't keep putting Band-Aids on it. This is where you need to prioritize upgrades, right? I can't get this equipment anymore. I've done everything I can, right? You've got these Frankenstein monsters out there of fixes to try to keep these lines running. And so that's part of the responsibility too, to kind of help them strategize and with their remediation plans and say, look, where can you afford to keep kind of playing games with this old equipment, and where are you at the end of your rope here?
Yeah. Go ahead, Nish.
The only other thing I was going to add is it's such a key point. Like it really is a balance between trying to sort of maximize the useful life of the assets or the equipment you currently own versus upgrades. I feel like that really is where a lot of consultation that we get, that's what we're helping folks with. Does it make sense for you? Does it not make sense for you? And here's why. I feel like we've seen a lot of traction in that.
Well, this discussion about just the environment, the equipment, the processes is really making me think of how dangerous it is to be in a steel plant, and that makes me think naturally then of safety and a lot of applications for safety as it relates to automation, but I'm not really sure how automation is helping to improve safety in heavy industrial environments like metals. So what are you all seeing, whether it be things that we're currently implementing for clients or even things that you think that companies should be thinking about but aren't?
I guess when you look at safety across the board, it's in every customer site we go to, it's posted everywhere, Jennifer. safety is job one. How many accidents in so many days? So safety is key. It's not just the morality of what's going on out there, but it's a very dangerous environment. I took Carm, Sean, and Mike to the steel shop where Charles was the other day, and they saw a lift of a 300-ton molten steel go over their heads into a casting operation. And you go, oh my God, if that thing dropped, what a disaster it would be. So safety is key. Technology is advanced in safety, and we've been part of it. Carm has led a lot of the efforts with these safety assessments with the Cincinnati group, looking at guarding, looking at PLC, safeguard PLCs through Rockwell, changing the old methodology of hardwired e-stop and rings into the PLC where it's a fail-stop type of environment. But along with that, just looking at safety procedures and lockout, tagout, and all those things that are part of our industry are incorporated in the automation and the technology that we provide.
You mentioned in a safety assessment. What does that process look like, Carm, when you work with clients on something like that?
So the safety assessments that we've been more successful at selling have really been more on the steel processing side. These are your companies that basically take your rolls of steel and they'll temper them. They'll the sheet steel and they'll temper them. They'll cut them to length and then distribute them out to customers for other manufacturing operations. So, but with those assessments, we'll bring our team out and they'll do investigation they'll interview the operators, see how they're interacting with the production lines, see which areas have the highest degree of risk of where they're interacting with mechanical points, where there's the proper guarding, where there's how well are things like light curtains operating, how the safety circuits are integrated together. So they'll look at it both from the mechanical side as well as from the electrical side, put together a report for the customer and say, look, these are all your levels of exposure within the line. But then, like I said, the important part is not just sitting there and pointing out where there's vulnerability, but watching the line run and seeing how the operators interact with it. Then they can apply a certain level of risk, right? So let's say you've got an area of the line that isn't properly guarded, but you don't have maintenance personnel or operators that interact with that portion of the line maybe once per year, right? So it's a lower level of risk. Whereas you've got an area of your production line which is not guarded properly, and you've got operators and maintenance that play in that area all day long, right? So it's not just calling out what's wrong with the line, but it's mapping out a remediation plan for our customers, saying where are you going to get your biggest bang for the buck as well.
And these are folks when they're conducting the assessments and doing the walkthroughs. I mean, these are folks that have steel experience and metals experience.
Not necessarily. They're more along the lines of being TUV certified to understand
certified.
Exactly, understanding risk and risk calculations than they are needing to be steel experts.
And they're just are these folks that you have out of your office? I know we have TUV folks that are spread throughout the company.
Yeah, both. We'll take individuals out of Westchester, and often, I mean, it helps to pair up our TUV specialists that maybe aren't as familiar, as intimate with the environment or the equipment that they're going to be taking a look at and assessing. It usually helps to have somebody who has more familiarity, so they know, okay, that it's worth peeking inside this cabinet. We don't have to look inside this cabinet. We don't have to go to this area.
Right.
It just kind of helps the process go more efficiently. So we'll typically try to pair up some resources from our office with some of the TUV resources from Westchester.
With the TUV certification, what does that mean for someone who may not know?
It is, I'll be honest, I don't know all the details to it. I know that it is it's like a 2-part test.
Okay.
That you have to be,
Well, that's fine. I've seen it lots of places and just wanted to harp on that for a minute. But going back to safety seems like it is crucially important within the metals industry. But one of the other areas that I think seems like the manufacturers are focusing on in metals and heavy industrial is efficiency and how they can improve that. Are there ways that we can help with that area? Or not just but I guess just automation in general. Dave, do you have?
I was just going to say, I mean, Dave can kind of give examples, but the old antiquated equipment tends to be one of the biggest sources of their efficiency issues, right? It's the downtime that it incurs. If something goes down, it's just down for way too long because either they don't have the right spares, they don't have the right equipment to replace and get it up and running, or they don't have the skill set to troubleshoot it and get the equipment up and running. So it's this old antiquated equipment that tends to cause the most efficiency issues.
We were talking to a customer this morning where they had a bunch of PLC fold panel views, things like that, that you're basically sourcing parts from eBay, right? And we see that many times. The pickle line we just revamped had compact 286s with mapped coprocessors. You probably don't know what that is, but they actually had this is their HMI system on this line. And this is their premier pickle line that feeds their whole plant. And it was just such a anomaly to see that equipment still in service. But those are the challenges we see every day, is that there's a lot of investment where they, like we were talking about the ROI, but then you find these different areas where, boy, that is really a bottleneck as far as the downtime they're having and the ability to service it with their own people.
The last thing I bought off eBay was actually a discontinued perfume, so I identify with bring it back. But you're getting on I think I want to pull a little bit more on the thread of like the impact that automation can have. I mean, obsolescence is obviously an issue. It's very serious if you're trying to source things off of eBay. But do we ever measure, or do our clients have like a measurable impact on any of these upgrades or new systems that they're installing on how it impacts their facility?
Oh, absolutely. I mean, you can't have a return on investment target without having measurable goals at the end. And even when we do our startups, so we look at how much productivity at 1 week out, 2 weeks out till we get to 100%. But all that is measured in tons per hour. They monitor downtime all across the board as far as operator downtime, strip breaks, crashes in the mill, electrical downtime. And typical of the old equipment, we're seeing a run rate maybe 5 to 8% electrical downtime in 2,000 turns, which is a lot. So the new equipment normally is 0.1 to 0.2% failure rate, which is about the industry standard. In other words, if you make this investment, you better have very good reliability. In the old days, we also had redundancy that you don't see anymore. So the reliability of the equipment is so good that automatic switchovers or RPUs, they used to call them, to go to another processor, have been eliminated because of how well the equipment is performing, just like your cell phone and everything else, as far as infant mortality or just failures due to issues with boards or electronics.
Part of it, we talked about obsolescence, but part of the other efficiencies that we can add, and Dave, you could throw in some examples there, but the way that the operators interface with the with the equipment, but the limitations that they have to see their process data and how they can interact with the line, how they can manually control the line with the older, more primitive HMI displays, giving them modern HMI, regardless of who the manufacturer is, and being able to link it to their systems just gives them so much better visibility into what's happening with the system, how they can interact with the system, right? Bringing in new operators and having to train them on how to work with these production lines. We can just give them so much more of an intuitive and kind of graphical representation to interface with the line, give them more controls, give them more visibility so that they can just run their processes that much more efficiently.
Yeah, that's a good point, Carm, because I'm sure you guys remember the old space movies from the 60s and 70s where they showed these big control stations and they had all these meters on it and 1,000 buttons. A lot of that is very similar to the operator stations that are in the industry today, especially older ones where you have these massive operator stations. And to Carm's point, we basically can condense a lot of that on a modern HMI screen and on panel view and give them better optics into the system. We can give them live operating screens where we can actually show well tracking through the line so they can see exactly when a product change will be made. They can look at diagnostics on those screens. So really it helps the operator, but it helps the training of an operator too, so that they don't have to learn all this on their own. It's basically a pattern that has been developed through technology and versus best practices from one guy to the next from turn to turn.
Yeah, and also just zooming out a bit on that too, it's a very good point. Like any more visibility you sort of give out to the operators, really that just means there's going to be smaller improvements in downtime reduction, which really kind of get towards a huge sort of dollar impact of savings you're getting as a business, especially as you're running very, very high tonnage. Dave mentioned 12,000 tons maybe earlier. That's a lot of tons. So yeah, there's a lot of money that impact that's sort of made through that. So.
That makes sense.
Going on reducing downtime, how can we help do that? Like with reduce the downtime or help them predict maintenance issues? Are there solutions that not just eTech Group, but automation in general can be implemented?
It's a huge topic, Jackie. I mean, we could look at predictive maintenance, wear and tear, but I'll give you an example of a typical welder in the steel industry where they weld a head and tail in together. And there's a lot of, I would call like CNC machine type of applications for a welder. But it used to be if something went wrong with the welder, line was down for hours and you had to go through drawings. You had to figure out limit switch or proc switch. Did this motor go or that go? Today, we have an HMI diagnostic screen, which basically will tell you why the welder isn't working. It'll actually flash up which limit switch isn't working. It'll take a picture of that limit switch to tell you where it is on the machine. And then it'll actually bring up the elementary drawing showing how it is wired back into the I/O point. And then another pull up will be the actual software where there's a ladder rung showing exactly where the limit switch is and how it energizes the coil for the run permissive. So if you look at the layers of how we apply technology for preventive maintenance, and then if there is an issue, how do you fix it very quickly? Something that would take hours takes 1 minute, 2 minutes to diagnose and get it up and running again.
So I think let me try to summarize what I'm taking away from this conversation, because admittedly, I have a lot to learn within the metals industry, but it sounds like this equipment has been around for a very long time. We've obviously, steel has been very important in building in all kinds of building and manufacturing, but the equipment is old and expensive and can't be down to replace it. It's not an option. So we're adding technology onto this existing equipment, but even that is still very expensive. But it sounds like it can have an impact within the facility. Is that correct? Is it just the capital expense to get it in that has had them?
That's really the key of all this, because take an example of the U.S. Steel Hot Strip Mill. Has 4 furnaces and runs 6 million tons a year. And downtime is so valuable to the whole operation. They can't go down. So there's always workarounds as far as how do you modernize that mill with minimal downtime. They've done strategies where they've actually had complete systems that they could switch in and out on 8-hour downturns to test and get back to the old systems. And that's where we really shine. We shine for many years integrating new technology and legacy systems during normal operation, because anybody can walk into these mills and say, yeah, I need 2 months to put this new system in. No, that's not going to happen. It would just kill the complete operation and their whole business. So we've done a good job, especially at the steel shop. Charles has been a master of putting in drives in those big vessel tilts, operator stations, the crane lifts. All these are done where he strategically tests things on a downturn, then switches back to an old system. Then he switches back to the new system only when it's ready to go, because it can't fail.
Sounds like an immense amount of pressure to be under.
It's a lot of work. It's hard to gauge, hours and cost estimates and all that, because it is a process to get to the end result where there's no downtime.
Dave, I could listen to you talk about this all day because you clearly have a lot of experience here. And I'm curious for your perspective on what have you, in your purview, is the biggest change or the biggest innovation maybe that you've seen in the metals space?
That's really the biggest innovation, and we can talk about that forever, is adaptive modeling. Adaptive modeling innovations as far as setup and throughput for these mills so they can optimize their processes. And then the other part of that is technology. I mean, if you walk through some of these motor rooms and you see how massive this equipment is, big contactors, big drives, just the overall I/O and how it was all put together, it was hardware intensive. Go out and see one of Dan McCullough or Anna's installations. It's in a little cabinet. All right. So everything that was done mechanically or with these large electrical components are done at a very low voltage level and with a fraction of the equipment. Now, of course, that converted into software versus hardware, but that's where I saw the biggest evolution when we get into this digitization of our industry. It's the minimal equipment, but more on the software and the innovation side as far as adaptive modeling and techniques to control the process.
Nish or Carm, do you have anything you have seen that has changed the most since you've been in the industry?
I think Dave hit it right on the head. The nail right on the head is the digitization of the industry and how it's been able to, I hate to say the word, but kind of shrink the space of, we talk about the massive capital investments, the massive space for this massive equipment. We've been able to kind of, shrink down that envelope with, like I said, modeling and the digitization of a lot of the power systems and the controls.
And Jackie, that's been the challenge. Carmen, I met with a really good customer a couple months ago, and he hired a really good engineer from Rose-Hulman, which is one of the top engineering schools in the Midwest, maybe in the country. And he kind of looked at the psychology or the strategy, what the customer's trying to do. Well, I'm going to hire these really, really good high-end electrical engineers, and I'm going to pay them these enormous salaries, and that they can learn my systems. Well, he found out that doesn't work. For one, he couldn't keep them. Second, there's not enough of them out there. So they have to push to get into the modern world because they're not going to be able to maintain it, and their workforce is aged just like the equipment. Many of their motor inspectors, technicians, and techs across the board, have 20, 30 years. There's quite a challenge out there for all our customers to get the right people to work on legacy systems and race to try to digitize so that it can be easily maintained.
I think that's what I said. The metals industry, this conversation has, again, been enlightening for me. You guys really are like just different challenges than what the conversations we've had with CPG and prepping for a couple other conversations, but it's just very different. It's been learned a lot. So thank you.
When you talk about we keep talking about these legacy systems over and over and over again. You keep hearing this repeated, but it's not only needing to find the people that understands how to interact with these systems, but they have to know the processes too, right? You can't just take anybody who says, I can program PLCs or HMIs and throw them into a steel mill and put them into a project and say, go ahead, have at it, right? We can't just put anybody on our projects. When you're sitting here and they're, coding and they're programming their PLCs and the drives, I mean, the amount, the coordination of drives on these lines, the work that we do and the math modeling, you have to know what's going on in the process. You have to be very intimate with what the process lines are doing to know how to program it. You're not just programming saying that something has to go from point A to point B. That's not how these systems work. There's so much more complexity to it, and calculating like I said, the math models and how much intelligence are you putting in the PLCs versus in the drives, and what the drives are going to control on the line versus what the PLCs are going to control. It's a different type of environment, and it works differently than, let's say food and bev or CPG. It's a lot less straightforward. You really have to know what's going on in the process to know how you need to be controlling it and how you should be representing it mathematically.
Nish, is there, from your perspective, what are you most excited about in terms of advancements in the metals space?
Yeah, I think what excites me the most is sort of the continued strengthening of core controls that we've sort of talked about, drives, PLCs, tension systems. When these foundational systems are upgraded, everything around them essentially improves as well. I'm sure Dave and Carm can speak to this way better than I can, but currently we're seeing a lot of sort of plants be able to run product mixes that they historically wouldn't be able to run just because they've upgraded their control systems. So essentially modernization has kind of unlocked revenue streams for these customers that maybe weren't being able to be supported historically. I think that's going to be a key. I think that's really the kind of tangible, practical innovation that really moves the needle in the metal space. I think this is an industry that, we talked about this a little bit, but maybe doesn't get all the love or the spotlight, but when modernization is practical and sort of impactful, I think we're going to continue seeing that. I think that is what, especially 2026 and onward, is going to see.
And if I may, before Jackie has some closing questions for you all, but We've talked a lot about different opportunities for digital transformation and upgrades and addressing all of these challenges. And there's, I would imagine, a fair amount of competition in this space. What do you all think is going to separate successful metals manufacturers from the rest?
I guess I can go first, Jennifer. It is a commodity, so it's the lowest cost commodity on the planet. So they're always trying to produce more with less. So a lot of it's on the energy side. We didn't touch on that, but we have done power system studies. We're looking at the total grids. We look at how they use energy and where's places where we can help as far as helping our customers reduce their energy footprint. Manpower reductions, we're looking at manpower reductions. So anywhere we can do cost reductions, yield improvements, productivity improvements is where we can provide the best service. To Carm's point, we're just not there to program a PLC. He made it very clear. It's the process knowledge. The process knowledge differentiates us from a competitor. That's why there is competition. But there's not a lot with our core competences as far as process lines, cold mills, hot mills, blast furnaces, electric arc furnaces. The whole gamut in the steel industry is where we really shine on the process side. Sure, anybody could program a PLC, but how do you perform that automation? How do you provide that strip transport, coordinated drive system so that you can provide the finished product the customer's looking for?
Yeah, I'd echo that too. I think really it's winners are companies in the space that are sort of modernizing with intention, right? So it's not just having the capital spending be done. It's sort of using that and sort of tying out your upgrades to a specific sort of throughput, through safety, through energy goals that are outstanding. I think doing it in that manner is really the more fruitful discussion that companies are starting to have, and I think we are going to continue seeing that as well.
Yeah. And the other thing that I'm sure Carmen could talk about is the investment we're making. We're talking about the customer's investment, but Carmen, you want to speak about how, since he's been our manager, we had a group of senior people that aren't there, so they would put their Superman capes on and go do things. Well, that wasn't sustainable, right? Mm-hmm. So I think the processes that we put in place, and Carm talked about project management, system factory acceptance tests, things that you brought as far as to make it more sustainable, reliable, and repeatable for our customers.
Yeah, and it's really the approach that I think of the steel industry, if any of our customers are going to differentiate, it's kind of the approach that they're going to have to take as well, right? You have to be adaptive. You have to realize part of adaptive is the workforce, right? What workforce do you have available, right? And a lot of our customers say, 30 years ago, this is how things worked. This is how it worked in the old days. Well, the old days don't exist anymore, right? Those, whether it's available education, process knowledge, even just, work ethic and work expectations, that continues to change. So you need to try to adapt your environment to what's outside of your four walls, right? That's the talent, that's the type of workforce that you're gonna have to deal with. So you have to start to make your work environment flexible to say, this is how I'm going to work effectively and efficiently with this type of labor, right? So when you talk about the steel industry, talk about what automation needs to do, well, certainly workforce reduction, the less dependent you are on manual labor, the less that you are kind of become a prisoner to it, but also the processes, right? We talked about the specialty and the processes, right? The more that you can automate, the more that you can bring in trusted partner who understands and can automate, the math models within these processes so that you don't need to require so much of this process knowledge, which continues to kind of deteriorate away with the workforce. You have to kind of, I hate to say it this way, but kind of dumb down the process, right? You need to simplify the process, right? Find a way to automate out the complexity to it and create a more simplified system so that you can have less reliance on these unicorns in the industry that know the specific process knowledge, know the specific system architecture and things like that. So, and that's kind of what we did as well. Instead of relying on these senior engineers that are experts in the process and experts at the specific area of the plant, we try to chop it up into bite-sized pieces and say, no, this is your role. This is your role of kind of being, you're going to project manage this, and these are your responsibilities. You've got your senior engineer. These are your responsibilities. We're going to kind of flood the area with these younger engineers, and this is how they're going to learn. This is how we're going to adapt them to the customer's needs, the systems that they have out there, the processes that they have out there. you have to kind of take the problems and chop them up into, smaller digestible chunks.
I think that's all the main questions we have, but Jen is right. I always like to end on a few less technical, more broader questions. So what is one lesson that you've learned the hard way in your career? Carm, would you like to kick us off?
No.
Sorry. No, he's no, I do not want to.
I have to think about that one. I have to think about that one. Nothing comes to mind right now. So Nish or Dave, you got some. Go ahead and chime in.
Yeah, you guys got an hour, but really the hardest part of our industry is our industry. No one can take it too lightly. I mean, it's the livelihood. If you go to Pittsburgh, Valley, Erie, Cleveland, it's third generation of steel workers, families that have worked in this industry for 100 years. And one thing that you can't take lightly, or the hard lessons is the seriousness of this industry. It's a very dangerous industry, and a lot of fatalities have happened over the years. And one hard lesson I've learned is don't take it too lightly. That's why these processes that we've talked about, where we have safety first, and then we also have piecemeal installation so that we don't shut these lines down. And that's why phones light up the way they do in our industry, because when those lines are down, everyone is worried about their job. They're worried about if they're going to fulfill their orders, or they're going to lose their advantage with their customers. So it's so serious, and that's what I've learned, I guess, over the years, is that you just don't take this lightly.
That's a good one.
Nish, do you have anything offhand?
No, the only other thing I would say, just generally, progress is never linear, especially in this industry. I think Dave talked about this a little bit, especially nowadays, you hear every other industry just growing double, triple digits, and maybe metals isn't that, but it is a very crucial piece of industry that sort of supports a lot of large infrastructure for us, and one that we are, certainly supported over the years, like Dave being there for 30 years, and one we're going to continue supporting. But I think generally, that the message that we also have internally as well is just progress is never linear, but you kind of take it one step at a time. So,
and I wanted to make a closing statement for everybody. Being one of the original owners and developing this business, and working GE over the years and developing the model there and bringing it on to Crown, to Glenmount, now ETech, to be able to be recognized as a system leader in technology, process knowledge, and have the bandwidth to pull something off as massive as this is a great statement for ETech and everybody that works for ETech. So we're going to work hard. Hopefully it catapults us to a level that not very many companies could ever do.
I like to ask one other, this is more fun. Poor Nish, I'm sorry, you've been on all these episodes. You're going to, I won't go to you first. If you could automate one thing in your life, what would it be? Harm, you got an answer for this one?
Automate one thing in my life.
Or Dave, if you've got one offhand.
Well, that's a good question, Jackie.
Yeah.
I mean, that's a zinger is with that one.
I will say, based on today, I feel like let's automate snow removal.
Well, they kind of already have. They have GPS controlled snow removal machines, so that's already kind of automated.
Not in my
life.
Yeah, they got robots that'll remove snow, and I don't know. I kind of, to avoid the mess in the kitchen and my wife cooking and making big messes that I got to clean up. It'd be nice if, in the Jetsons, you just kind of push a button on a machine, say what you want to eat, and it just kind of comes out, and you can have whatever you want, and this way you've got less food waste and less prep time and less cleaning time, and I think
my dinner on
can we automate individual food production? That would be
Nish
something.
Had this answer too.
Yeah, I was just gonna say we said the same thing. Meal prep.
What about you, Dave?
I guess in general, you wish you could automate everything. You could automate your wife so that she doesn't do the things she does to you and aggravate the hell out of you. The kids, wish you could automate that, and they were in a perfect structure and made your life simple, along with your coffee maker. But I guess in business, and I've said this many times to groups, I wish I could automate or had a valve on the wall in my office where I could open up and have the orders come out as I need them for the people I had, and I could close it off because I don't have enough people. And if I could automate that order flow and the margin flow and everything with that little valve or a little loop, so that I didn't stress out the engineers and stress out the managers and stress out all that, that would be one thing in life, if you could wave your magic wand and automate.
Predictive maintenance, as it were.
Predictive orders. Yeah.
We should ask for a couple valves, Dave. not just.
Well, you guys have been very generous with your time. We really appreciate you coming on and joining us. Dave, I think Jackie's ears perked up when you mentioned talking about energy. I think that's a future episode, so thank you for that. You've already signed on, didn't realize it, but really appreciate your insights, your time, and hope to see you again on Beyond Tech.
Thanks for putting us all together.
Thanks, guys.
Thank you.
Thanks, guys.
Take care. Bye.